All right. So let's work on this problem. Find the dimensions of the box with no lid that has minimum surface area if the volume is 200 cubic meters. Okay, so let me draw our box here and label some dimensions. All right, we'll go with the width is x, or the length here is x, the width is y, and our height is z. And so our surface area equation would be what? Well, we've only got the base here is x comma y, right? So, right, we would just have xy, but we wouldn't have another xy, so it would just be one xy. But the others, like the yz, we'd have this side and then that side, so 2yz. And then we have 2xe, okay? Now, the thing is, we also have that the volume, which would just be the volume of the box, would just be xyz, right? But we have that equal, and so what that allows us then to do, is get, this equation is in 3 variables. Right here, solve it for z. Z equals 200xy, and so we can substitute that in for z here, and we have s equals xy plus 2y times 200 over xy plus 2x times 200 over xy, and now we just have an xy equation, and we can find our minimum based off of our partial derivatives here. It simplifies here, of course, the y's cancel, so xy plus 400 over x, and this would be 400 over y. Okay? All right. So what we've come to find out is our minimum values. Where are they going to occur? When the gradient is 0, partial derivatives are 0. So yeah, let's get our partial derivatives with respect to x of this function here. So that would be y, and this being 400x to the minus 1, right there, would be negative 400x to the minus 2, which we could write as y minus 400 over x squared. And then we'd have the partial with respect to y, very similar, wouldn't it? Partial with respect to y would be x, and then that would be 0, and then that would be 400 y to the minus 1, so that would be minus 400 y to the minus 2, or x minus 400 over y squared. And so minimum, set them equal to 0. Okay. So what we can do is, there's different ways of solving it. But let's just solve this one for y. We have y equals 400 over x squared, which we can substitute back into this one. which, this one would be x equals 400 over y squared. To make it easier to substitute, though, let's make this multiply both sides by y squared. So we have xy squared equals 400, and then we won't have those complex fractions. So now we can drop that in right in there for my y. Yep. So that would be x times y squared, but I'm going to put in 400 over x squared for the y. So it would be 400 over x squared squared equals 400, which that would mean x times, what was that, 160,000, 400 squared, over x to the fourth, that equals 400. So that would be 160,000 over x cubed equals 400. Okay. So multiply by x cubed, divide by 400. So we'd have 160,000 over 400 equals x cubed, which that's just going to be 400. 400, I think, because those will cancel, right? Divide by 100. So x cubed is 400, which means cube root of 400. I don't think it's a nice number. Let's just call it, yeah. Yeah, it'd just be the cube root of 400. Now, what we'd also see then, as far as the y, so then we could plug in, we could find our y from here. So let me erase a little bit of this. I think we're okay on erasing this. Yeah. So we got x equals, really just need this, and this now. Okay, so x equals the cube root of 400. Y then would be 400 divided by x cubed, so that'd be cube root of 400, squared, 400 over x squared, so it'd be 400 over cube root of 400 squared. But that's a little too complicated here because, if you'll notice, that's 400 to the 2/3, right? Cube root of 400 squared. If I multiply that by 400, another cube root, top and bottom, then this times this would just be so this would be 400 times the cube root of 400. So that would just be 400 to the, add the exponents. So it'd be 3/3. So that's why we did it, because it just, no, it's 1/3, yeah. Yeah, multiply by the cube root. So this is just 400. Okay. And then that cancels, so we come up with the cube root of 400. So y is the cube root of 400, same as x. Then we have, find the dimensions, so z would be 200 over xy, right? That's what we started with here. And so if we take 200 over the cube root of 400, that's x, times the cube root of 400, that's y. So we have 200 over 400 to the 2/3 again. Guess what we're going to do there? Multiply by the cube root of 400 again, 400 to the 1/3. So again, we'll have here, that's just 400, so it's 200. That's the cube root of 400. and that's 400. So that's a half. So the z comes out to be half of what x and y was. Okay. So the x is the cube root of 400. So basically your height is half of what your base dimensions are. Okay.